Quick video on our basic models. We've got now 4 different models: linear, exponential, logarithmic, and power models, each with their basic equations or general equations. Within each of these, A is our value that's going to basically tell us where the function is or where that graph is, and B is going to give us the general shape of the graph. B, for each of these 4 functions, is the most important of the 2 values. But other than that, we've got a few more things that we can talk about with the linear model. If B, or with each of these models, with linear though specifically, if B is greater than 0, then we've got an increasing function and there's no concavity. If B is less than 0 with the linear model, we've got a decreasing function, and again, linear models have no concavity. So it's not concave up, nor is it concave down. That shouldn't be much of a surprise. We've talked enough about exponential models, and you've learned about those in the past. With linear models. With an exponential model, assuming A is greater than 0, if B is greater than 1, we've got an increasing and concave up function. If B is less than 1, but B always has to be greater than 0, we've got a decreasing and still concave up function. A little graph of each of those. Also notice that regardless of A and B, the x-axis is a horizontal asymptote. Again, it doesn't matter what A and B are, the x-axis will always be a horizontal asymptote for an exponential model. And then if A is negative, that's like performing a transformation where we flip everything across the x-axis. So if A is negative, then we have, let's see. If B is greater than 0 and A is negative, we're going to flip this model across the x-axis. So we'll have decreasing and concave down. And if B is less than 1, again, still greater than 0, we'll flip this model across the x-axis and we'll have increasing and concave down. Okay. So those are the linear and exponential models. For logarithmic and power models, our log model, y equals a plus b ln x. The basic log model, y equals ln x. We'll have a vertical asymptote of the y-axis. And it'll increase forever. Then if b is negative, we'll have y equals b ln x. Something like this. So for a logarithmic model, we've got, concave down and increasing, or concave up and decreasing. Those are the 2 options we've got for a logarithmic model, both of which have the y-axis as a vertical asymptote. Power model is going to be kind of the Swiss Army knife of models. It'll work in several different scenarios. So y equals a times x to the b. First, assuming b is greater than 0 and a is greater than 0, we have a concave up and increasing model. we'll start at the origin, be concave up and increasing. Notice that every one of these power models will go through the origin no matter what. But if B is greater than 0 and A is less than 0, it's going to flip this model across the x-axis. So we will have concave down and decreasing. So it'll still go through the origin, and it'll decrease like that. If B is less than, if B is less than 1, but greater than 0, and if A is greater than 0, we have concave down and increasing. This looks like the graph of y equals root x, because root x is just x to the 1/2. And then if B is less than 1 and A is less than 0, we have concave up and decreasing. So it'll still go through the origin, but we'll flip this model to the other side of the x-axis. Those are our 4 basic models and some of the basic ideas for each. If you have questions, as usual, please let me know.